Hello, my name is Marcos Magalhães, and first of all, I would like to thank the opportunity to present our work here. It is entitled BVAR Analysis on Channels of Monetary Policy Transmission in Brazil, and it was done in partnership with two researchers from the same university I am part of, that is Federal University of Ceará in Brazil. The researchers are Francisco Rocha and Attila Brilhante. So, the name of the paper is very suggestive of what we will be doing here today. So, in this work, we study the generalized impulse response functions and the variance decomposition of a BVAR model. And here we analyze the dynamic interface between traditional channels of monetary policy transmission, inflation, and real GDP. And to do this, we use the Lederman and Minnesota priors. So, to analyze the pattern of how the model variables move, we equate the monetary policy transmission channels with the impulse variables, while inflation and real GDP are the response variables. So the BVAR analysis we will be doing here covers the sample period from 2009 and 2019, and it consists of 7 variables. 5 of them are the impulse ones, namely free real credit, short-term interest rates, that is our Selic here in Brazil, inflation prediction, in the São Paulo Stock Exchange Index, Ibovespa, and finally nominal exchange rates, and 2 response variables that are real GDP and inflation. So a question one might ask is why use BVAR model instead of the standard auto-regressive vector? We could list here all the differences between them, but by way of elucidation, I will list just the main ones. And more specifically for this paper, the reason to resort to BVAR model to analyze how the channel transmissions of monetary policy affect the output inflation couple are the following. First, it provides the solution to the question addressed by over-parameterization, usually observed in VAR models representative of classical econometrics. Unlike VAR-oriented techniques that are deprived of robustness, BVAR model configurates as a rarer, robust one to value auto-regressive vector, giving rise to a more reasonable analysis with respect to predictions about variables along with input response functions and variance decomposition. Secondly, BVAR also solves the problem instigated by the order of variable integrations, reducing the relevance of the sample size. In a nutshell, we could say BVAR differs with standard VAR models in that the model parameters are treated as random variables with prior probabilities rather than fixed values. The Lederman-Minnesota method is composed by the following priors: mu1, lambda1, lambda2, and lambda3. It is a set of hyperparameters. mu1 is the prior mean, and it could be the case to equate such prior to 1 or even closer to 1 in order to capture a sort of persistence in economic and financial time series. In the study, we equate mu1 to be equal to 1 because of 7 variables that make up BVAR. 5 of them are integrated on first order. 2 of them, on the other hand, inflation and inflation prediction, are stationary. However, if the VAR series are in difference or in growth rate, mu1 equal to 0 would be more convenient. Lambda 1 is the global adherence over the variance and controls the global adherence of our beta. It should be close to 0 if there is more certainty about the prior. That is, by establishing lambda 1 to be equal to 0.1, the prior's information is allowed to dominate the sample information. In such case, the prior is relatively strong. In this work, we regard lambda 1 to be equal to 6, which allows both the calibrated value and the sample to play a significant role in the quality of BVAR adjustment. Lambda 2, in turn, controls the importance of the leg of variable j in the ith BVAR equation and is called cross-variable weights. If cross-legs play a relevant role in each equation under the model, then lambda 2 should be closer to 1. In the study, we equate lambda 2 to 0.99, as it is assumed that cross-legs play a relevant role in each model equation, given the dynamic intercommunication in the impulse variables of the transmission channels and the response variables that are GDP and inflation from the BVAR. Finally, lambda 3 is greater than 0 and represents the relative adherence over the variance of the legs of the variables, and so is the declining rate of these legs. If lambda 3 is equal to 1, then there is a linear decline in these legs. Therefore, this prior was calibrated equal to unity. So, after the calibration of the BVAR priors, the quality of the established priors was tested by looking at BVAR prediction errors compared to prediction errors of an unrestricted VAR or standard VAR. This test was performed and the BVAR forecast errors were mostly lower than the standard VAR forecast errors. So we can check here the RMSE of the VAR model are always greater than BVAR ones, where we can check in these tables, table A1 and table A2. The model consists of 7 variables. 5 of them make up the traditional transmission channels of monetary policy that we are calling them of impulse variables in the paper. And they are, again, free will credit, short-term interest rate, SELIC, inflation prediction, São Paulo Stock Exchange Index, Ibovespa, and the nominal exchange rate index. And on the other hand, 2 of them are our response variables. They are the real GDP and the broad consumer price index, EPCA, the inflation in the model. And they are collected from government databases, IPEA data, Central Bank of Brazil, and also Bloomberg. As I said before, the model is adjusted using monthly data from January 2009 to December 2019 in order to avoid COVID-19 effects. The variables are used in level, although 5 of them that make up BVAR model are integrated of first order, and the 6 to avoid imposing possibly incorrect restrictions on the model according to Sins and Ullig and Stock-Watson. That is, even with I1 variables, the residuals continue to be stationary, given the inclusion of differences of variables in level in the model. So equation 1 is said to be, in a simplified way, the Bayesian VAR model to be estimated. And this model is estimated using 6 legs. We used the Schwartz, Akaik, Hanna-Quinn information criteria to use these 6 legs. The model also does not get residual autocorrelation problem. And finally, the generalized method for impulse response functions is robust to modification in the order of variables that enter the BVAR. From now on, we will analyze the model results. And the main results of the impulse response functions of the BVAR estimated model on real GDP are the following. First, an increase in short-term interest rates, SELIC, leads to a long-term interest rate increasing and consequently a reduction in GDP. Secondly, the free credit does not have a significant impact on Brazilian GDP, given the low credit GDP ratio observed in Brazil, and it is in accordance to the paper of Bogdansky. Finally, a shock in inflation expectations results in a decreasing trajectory of GDP, effect consistent with the Fisher effect. Changing the perspective now to inflation, we have that the main results of the impulse response functions of the model on this variable were the following. First, a shock at Selic, that is again our short-term interest rate, reduces inflation in the first 2 months, so there is no price puzzle in the model. Secondly, a credit shock does not cause significant pressures on inflation, and that is probably because of the lower credit over GDP ratio observed in Brazilian economy. Finally, the inflation does not show a well-defined path after a shock in asset prices. We can check this in this last panel in this figure. And these and other additional results are described in the paper, and I invite the audience to check them out there. In this last slide, I expose the variance decomposition of forecast errors. And it showed that GDP in the short term has its forecast errors explained by its own shocks, 70% on average. However, in the medium term, their forecast errors are explained by their own shocks, just around 35%, by inflation shocks, 34%, and by interest rate shocks, 20%. The other transmission channels do not have, in the short and medium terms, significant influence on GDP forecast errors, except the asset prices that are represented by Ibovespa. At last, inflation forecast errors are explained in the short term mainly by their own shocks, 85% on average. In the medium term, inflation forecast errors are explained 68% by inflation itself, 6% by GDP, and the other transmission channels participate individually, each one with approximately 6%. Finally, a robustness analysis was performed. We include the commodity price variable in the estimated BVAR, so the model was estimated assuming that the commodity price variable is the most exogenous BVAR variables, and the inclusion of the commodity prices into BVAR did not result in significant changes in the generalized impulse response functions. With that, I finish my presentation. Thank you very much again for the space, and I am open to discussions. Thank you very much.